In this video, I'd like to talk about using similar triangles. And with this example problem, you can see that we have a larger triangle and a couple smaller triangles within this bigger triangle. And with the given information, we need to find the length of LW. So that's the hypotenuse in this larger triangle. And this type of problem can be a little bit tricky, but we can use the properties of similar triangles to find this missing side length. And we can start by noticing that we have information on this smaller triangle here, this triangle YAL, and we can prove that this smaller triangle is similar to the big triangle WYL. Since notice that they each have a 90-degree angle and they each share this angle L. And remember that when two triangles share two equal angles, you can always prove that they actually share the third angle as well. Meaning that we can prove that this angle here, AYL, is equal to this angle W. So anytime that triangles share two sets of equal angles, they actually share three sets of equal angles. So if you can prove they have two in common, then therefore you know that they actually have three in common. And you can set up an equation and prove that to yourself. So let's start by first redrawing this triangle YAL so that it's oriented the same way as the bigger triangle. And when you redraw these, it will make it a little bit easier to set up the proportionality equations. So we have this triangle YAL, where this is the 90-degree angle. And we can write that triangle YAL is similar to the bigger triangle, which is triangle WYL. And we just need to be careful that we write this correctly and make sure that the corresponding angles match up. Since we can see that this angle Y at the vertex Y in the smaller triangle is equal to angle W in the bigger triangle, the right angles are at the vertex A and the vertex Y in the bigger triangle, and angle L matches up in both triangles since those are equal. So with this in mind, now that we know how to write the similarity relationship, let's put in our information. We have that this smaller side is 3.5. This middle side is 7.0. And we can use the Pythagorean theorem to find this side YL. And we'll need to do that since we need to find the hypotenuse in the big triangle. So we'll need to know the hypotenuse in the smaller triangle. And we know that with right triangles, the Pythagorean theorem is just a squared plus b squared is c squared, where a and b, these are the legs of the triangle, and c is the hypotenuse. And it doesn't matter which one we call a and b, just as long as a and b are the legs next to the right angle. So let's just plug in our information. We have that 7 squared plus 3.5 squared is equal to c squared. And if you carry out this calculation, or if you put it in a calculator, you'll find that the left-hand side of the equation is 61.25. And to solve for c, we're just going to take a square root of each side. So c is the square root of 61.25. And at this point, we could round this answer, but it's going to be an irrational number. So it's probably going to be best to save rounding towards the end, since if you round along the way, then your final answer is going to be off by a little bit more than you want. Essentially, the more times you round something, the further away your final answer gets from the true value. So let's save all of our rounding towards the end. But this side right here, which is really LY in the bigger triangle, this is the square root of 61.25. And to find LW, since that's our goal, we also need to know WY, since If we know that side, then we can use the Pythagorean theorem again to find WL, or LW. So let's make a little bit of room, and we can use the properties of similar triangles to figure out WY, this middle side in the larger triangle. Since we can set up proportionality relationships, since we know similar triangles are proportional. Essentially, we know that the ratio of corresponding sides is always equal to the same number. We can write that the ratio of the small sides in each of these triangles, so LY from the bigger triangle divided by AL, this is equal to the ratio of the middle sides in each of the triangles. So we can take the middle side in the big triangle, that is WY, divided by the middle side in the smaller triangle, which is AY. And if we wanted, we can even set this equal to the ratio of the large sides in each of these triangles, which would be LW divided by LY. But at this point, we really just need these two since that's what we have information on. So let's plug in that information. We have Ly, which we know is the square root of 61.25. We have AL, which is 3.5. We are looking for WY, and AY is 7. So to solve for WY, let's multiply each side by 7, and notice that 7 divided by 3.5 is just 2. And what we can notice is that in the bigger triangle that the middle side is twice as big as the smaller side. And that should make sense because these triangles are scaled versions of each other. And in the smaller triangle, the middle side is also twice as big as the smallest side. So now let's write in that this side length here, WY, this is twice the square root of 61.25. And from here we can use the Pythagorean theorem again. This is our hypotenuse, which if we want we can call it C, but I'm not going to write that so that we don't get the lettering confused. But basically, we're going to take each of the legs and square them. So we have 61.25, or the square root of 61.25, and we'll square that, plus twice the square root of 61.25, and we'll square that, and this is equal to the hypotenuse, WL, and actually let me write it as LW since that's what the problem asks us to find, and we'll square that. And with this, we could put it into the calculator, or we could simplify it along the way, since notice that square and square root, these are going to cancel each other out. So we'll get 61.25 here, and when you square this one, 2 squared is 4, and again, the square root and square cancel, so you get 4 times 61.25. If you add that to the 1, 61.25, you actually get 5 times 61.25, and this is equal to LW squared, and we'll take a square root of each side, but ultimately we'll have to put this into the calculator anyways. So let me just make a little bit more room, and we can write that LW is just the square root of this, which if we put it into the calculator, we actually get a nice clean decimal. This is just 17.5. And we can put that into our box here. Excuse me, this would be 17.5. Now, an alternate approach is that we can even look at this triangle WAY, and notice that we have the hypotenuse and this leg right here. So we can find this missing leg AW and then just add 3.5 to that. And if you set up your Pythagorean theorem with this triangle here, this essentially middle-sized triangle in these 3 triangles here, then you will square the hypotenuse, you will subtract this side squared, and to find AW, you will take a square root of that, and what you'll find is that AW is 14, and to find LW, you can add 3.5, and you'll end up at the same answer, 17.5. So that's one way to verify or to check that this answer does make sense.